Welcome, folks, to our lesson 3, Matrix Form 3, lesson 3. So I did the introduction, then I have done lesson 2, addition and subtraction, which we don't need to waste time there. Okay, now lesson 3, I'm dealing with multiplication in twofold. What do I want to achieve in this lesson? What will you test yourself if you have achieved something? 1. Multiplication by scalar. That is a figure, or in algebra, coefficient of a matrix. A figure that appears before a matrix. 2. Matrix times matrix. Okay? So let us look at this data. I have some sample data, an extraction from the first lesson. I have marks here for bio and chem for 3 students. Okay, these are 3 students. You can say student 1. Okay, this is student 1, student 2, and student 3. So they got these marks. Okay, they got those marks. They were out of 10. Okay, this is out of 10, right? Now I want these marks. Remember how I started? These marks were tabulated. Okay, then I extracted these figures and put them in a bracket. Then we call this now a matrix. Now this is out of 10. Okay, out of 10. I want to convert these marks so that they are percentage out of 100. Okay, so what do I do? Ideally, I would do 6 out of 10 times 100. Then I'll get the percentage for student 1 in biology. I would do the same, 8 out of 10 times 100. Okay, that gives me 80. I'll do the same here, 9 out of 10 times 100. It will give me 90, and so on. Okay, so you can see it is marks out of 10 times 100. Now 100 over 10 give us a multiplying factor 10. Okay, any mark there, it is out of 10. And since we want percentage, we multiply times 100. Now I'm saying 100 divided by 10 gives us 10. So every figure there is supposed to be multiplied by 10. Hence, I've given you a shortcut. You just put scalar 10. Okay? So when I multiply this, every element, do you remember element? Members in that family. What is the family name? Matrix. Okay? And then we knew how to name the members, the elements, using intersection of row and column. Okay, so these children, every of them will be multiplied by 10, by 10, by 10. And that is what we call multiplication by scalar. So you can finish. Your end product should have the following elements in row form: 60, 90, 80, then second row, 80, 70, 50. Folks, that is how we multiply. Okay? A coefficient, that figure written just before the bracket, it affects every element at a time. Look at this example. This is now my scalar, a half. My scalar is a half. The elements are in row form 12, 0, 4, 8. You see, I've changed my language. I must tell you, I'm naming them left, right, or up, down. So if I tell you left, right, it is as good as saying in row form. If I tell you up, down, that means column form. Okay? So this half multiplies 12, which you get 6. This half multiplies 0, you get 0. This half multiplies 4, you get 2. And this same half multiply 8, you get 4. This is a simple form, just like in algebra. Okay? Just like in algebra. Every element inside bracket is affected by a coefficient. So this scalar also goes and affects every element, and this is the result. So remember here, you have to finish for me. This backs you up that the scalar can be a whole figure, a fraction, positive or negative. That is done. Objective 2, matrix by matrix. But that I have to build it. Okay? So I want us first to study this table, and then I'll change the position of the camera. So we have mango. This is like going to supermarket or going to a market. So there are 3 people here: Alex, Brian, and Cosmos. Cosmos. Alex, Brian, and Cosmos. Okay? These people bought the following fruits: mango, banana, and apples, as shown in the table. Okay? So you have a table. Shows you, like, Alex bought 40 mangoes, 15 bananas, 5 apples. What about Brian? 20 mangoes, 30 banana, 25 apples. And Cosmos, only 10 mangoes, but 50 bananas and 40 apples. It's a table. If I extract and put brackets, what does it become? Right, matrix. Right? Table. Simple. Extract things, you get a matrix. Now, what was the price? A mango cost 20 shillings, a banana cost 10, and an apple cost 40. I've written in which form? Do you remember? Introduction. I've written them in column form. The price is in column form. Now, let us see. I want to focus so that we come here. Okay? I want to focus so that we come here. I want us to see both this and this. So we change the position of the camera a bit. Yes, we can see. I can see this line up to here. And then I can see the people and items prices. I want us to find a way of getting how much did Alex spend. If I want how much did Alex spend on mangoes, it will be 40 times 20. Look at that. And if I want to know how much he spent on bananas, it will be the number of bananas times price. And if I want to know how much he spent on apples, it will be 5 times 40. Now, I want you to notice one thing. You know this, Alex? I am multiplying the number of fruits times their corresponding prices along the same line. Okay? I've arranged them on the same line. Now I come to Brian. Brian is here. How much did he spend on mango? It will be 20 mangoes, and each mango is 20 bob. Then, what about bananas? He had 30 bananas, and each is costing 10. And what about if I come to apple? It is 25 multiplied by 40. Again, you can see I've arranged the money spent in each type of fruit along the same straight line for Brian. And the same thing you do for Cosmos. You can see. I'm trying to show you that what you know, we have just added word matrix, but it is live situation on the ground. This is what you get. Okay? So quickly, we can do even the total. But before I do the total, remember, the arrangement is specific. It gives you an idea. This is what was spent in mango, what was spent in banana, what was spent in apple. And now, if we multiply and get the total, we get the total expenditure from Alex. We can do it. We can do it here. I will write it just somewhere here. Okay? Here. Now, this is 800 plus 150 plus 200. 800 and 200 is 1,000. And then we add 150. So I have 1,150. This is money. Okay, look at that. Arrangement matters because you are doing science. I have 400. I have 300. That is 7. And then here, what is that? 40 by 20. These are 1,000. So these are 1,000, 300, 700. So 1,700. So this is cash. And then what about this? This is 16. Keep it. 16. Keep it. You know where that comes from? Yes. Keep it. Keeping in. Keep it. So this is 16. This is 200. This is 500. So we can do simple. 500 and 200, 700. 700 plus 1,600. That is 23, if I'm not wrong. Look at that. Look at that. Now this information can easily be done like this. I can do this. Can I? Yeah, can do that. So I want to write the prices here: 20, 10, 40. And here I extract these figures. We had 40, we had 20, we had 10. Here 15, 30, 50. Then here 5, 25, and then 40. Now look at that. Nice. You have extracted the number of fruits. You have extracted the price for each type. And now you are getting the amount. 1,150. Then 1,700. Then 2,300. Okay? And if you are asked about the order, what would you do? I would write. What is the order here? Can we focus down? I focus down a bit because I can see the camera is now out of focus. That can do. This is 3 by 3. And then this is 3 by 1. I want you to be writing this so that you don't forget. Okay? So this is 3 by 3. And then this is 3 by 1. Okay? What have we done? If you are observant, this is row 1. And this is column 1. So we've done that. Check up here. 40 by 20 here. See? and then 15 by 10 here, and then 5 by here, and the answer must remain on the same straight line of R1. Okay, then we came to Brian. So it is like this. Okay, I took this and multiplied by that. Okay, I took that, multiplied by that. So what does it mean? That for multiplication to work, multiplication requires, this is conclusion, that members of R1 must be the same, equal to members of C. So members of R1 must equal to members of C1. For multiplication to take place, this must be there. In short, when you write, you will see this must be the same. It must be the same, this and that. So we shall repeat, not repeat really, we shall do now SPSS. It's like a problem solving session, so that you see how this is implemented. But I'm sure if you read your book now, you'll be able to do some multiplication. Remember, R1, if there are 3 members, the column of the next must also have 3. Okay? If there are 2 members here, then the column that you have here must also be 2 members, because it's partnership. The number of items times its corresponding price. Okay? What we've done is, for each fruit, it has its price. For another fruit, it has its price. So when you are writing your matrices, you should be able to account for total expenditure. Total expenditure, because that is what you'll be getting in exam. You'll be getting items, maybe sacks of rice, maize, and beans. Okay? Maize, rice, and beans. So what is the number of sacks bought? What is the price of rice? What is the price of maize? What is the price of beans? So if school A is required to account, you should be able to tell us, for rice, it is 100 sacks times 2,000, plus beans, 200 sacks times 3,000, plus maize, 400 sacks times 2,500. That must be on the same line for a particular school or institution. It must be the same. If I'm a shopkeeper, shop 1 bought mandazi, cakes, and bread. If you want to know how much I spent, there must be a particular way you will arrange the number of items and the corresponding prices. And what guides you? It must be done on a straight line, so that if there is shop number 2 with different number of items, but prices will remain the same, then we should be able to get them on a straight line. And when you extract and put them in a matrix, 2 matrices, matrix times matrix, you should be able to make them multiply. And those matrices are called compatible. Compatible. What will show you that they are compatible? If matrix 1 is 2 by 3, then the other matrix is maybe 3 by 4. If you see the inner numbers are the same, then the two matrices are compatible and therefore they can be multiplied. Subscribe, tell your neighbor, stay safe. When you subscribe, you get notification so that we move on. I've started with lesson 1, there was lesson 2, this is lesson 3. If you are a beginner, don't jump stages. That's why I coded them lesson 1, lesson 2, lesson 3. So you cannot go to lesson 4 when you don't know anything. So if you have not done matrices, move with me. You will be a champion. See you.